Okay, my name is Juan Luis Cano, and I'm managing the operations for the information system at ESA's NEO Coordination Center in Frascati, Italy. And I'm representing today our whole team that you see here in the screen at ESA and also at industry that support all our activities in the developments that I will present to you in a few seconds. So what do we do at the NEO Coordination Center? These are our main activities. For those of you who don't know about ourselves, about us, we do follow-up of asteroids by means of astronomical observations, and our colleague Marco Michele will speak of this later and will present more details. We do operate a web portal that I will show you in a few seconds, where we provide useful information on risk, close approaches, and priority list, among other things. But in order to collect that information and to have that information available, we have running also an orbit determination system and an impact monitoring system. And we also participate in outreach and communication activities. So the purpose of my talk today is to provide to you the updates in that we have gone through in these 2 years from the last PDC. But first of all, for those of you who don't know our portal, this is it. As Lindy was commenting, we have already reached the 20,000 mark there, and we already commented on that as well. This is our site. There are a number of services here. Just I will go through them quickly, but if you want to visit us, this is our web portal, neo.ssa.esa.int. And what you will find there is a number of applications and services like our news archive, our monthly newsletter archive, our search tool for asteroids, most importantly, our risk page with all the risky asteroids, a priority list in order to look for interesting objects, the close approaches list, an advanced search facility, and some graphical representation tools. There are also some other tools that you will find there as a new population simulation tool, a new propagation. But okay, I didn't want to mention everything here today. But as I said before, what I wanted to comment today is on the main things that have changed from the last PDC, and among the most important things that we have had in our system is the start of operations of the orbit determination system. Until 2 years ago, we were still relying on the information provided by NeoDICE at the University of Pisa. And since 2017, we have already the system migrated to our facilities, and we are able to compute collect all the information from the MPC on an hourly, daily, weekly, and monthly basis, and produce the accurate orbits, taking into account a standard dynamical model, weighted on linear squares method, and differential correlation algorithm. We apply the agreed weighting and biasing schemes to the information. We also have an algorithm for rejection of outliers, and treat the ground efficiency whenever we have that. And all this information is reported in the web portal. And this allows us to provide all this information, for example, for a given case. This is 2006 QV89. This is a case that will have a close approach in September, and all that information that is derived from the orbit determination system comes into this web page. If you go to the tab of orbit properties, you will have all that information that has been computed with this orbit determination system, and also the covariance matrix associated to the orbital elements or whatever representation of the orbit that we provide there. We provide also, as information computed by the orbit determination system, the number of close approaches that this object had in the past and will have in the future, and some other information as all the observations used for this orbit determination process, plus the residuals obtained from the activity. The second main piece that is currently under final migration is not completely migrated yet, but it's under final migration, is the impact monitoring system, also migrated from the NeoDICE tool developed 20 years ago. And it propagates the orbits 100 years. It scores its asteroid to see whether it has chances to pass close by the Earth. And in terms of that scoring value, if it's high enough, it will trigger a process to have a very detailed propagation process based on a line of variations algorithm in order to detect when and in what terms the object would have probabilities of impacting the Earth, and subsequently compute the impact probabilities. This information is provided in our risk page. You have here one that is from a few days ago. You have here QV89, as I was mentioning before. It has chances of impacting the Earth in September, and you will be able to find all this information here. Our colleague Fabrizio Bernardi will speak of all these migration activities after my talk. Okay, some other new features in the web portal. This web portal still is based on reading information from NeoDICE, but in a few months we will be providing information that is being computed by the software migrated in our center. We are also providing historical information on the evolution of the impact probability. So if you clicked on these columns here, for example, 2006 QV89, you have the evolution on the impact probability, and you could also make a plot out of it if you click into the plot generation utility. Okay, so as I commented, these are the two main advances that we have had in this last period, but there have been other ones. We have evolved in the image database that was from 2016 already there, but we have been implementing a number of tools to make checks on the fits headers that have been agreed in the last period to have certain information within it. And there have been some tools that have been developed in order to validate the contents of the fits header and ingest all those images in the system. This will be very important for us in the future when the FlyEye comes into play, because we will be completely filled with images coming from the FlyEye, and this system will be important for us to archive and have all that information available for the community. Another step which is important for us is the inclusion of a tool to automatically import the data on the physical properties database maintained by Gerhard Hahn from the DLR. And we have facilitated this by a means of an interface that allows the automatic ingestion of all that data, and such that the physical properties data that is provided there is accurate and the last information available on these aspects. The tool is under validation now, and it should be available within this year. Finally, we have evolved as well in our system in more modern practices in what regards software development and software maintenance. And we have now a system that allows automated continuous integration, continuous deployment, and fully controlled deployment by means of a DevOps approach, which has enormously facilitated our activities in what regards the software maintenance and software updates of all the pieces that we have in our system. So this has been, let's say, transversal to us, but it's been very important. And just to finish a couple of slides on future developments, we are going to provide we're going to be or to have a new web portal in the near future in 1 year. So we'll change completely the look and feel of our web portal. We'll provide the asteroid ephemeris soon, a fireball information system, new orbit visualization tools, the possibility to integrate the information collected by the NeoSeal2 project, and an evolution on the DevOps system that I just mentioned to you. As a summary, well, in this last period, we have an important addition to our system, which has been the orbit determination system and the impact monitoring system. These are paramount for us, and as they provide us with independence for the provision of all the information to the community. This information has come from NeoDICE, some aggregation of the system. And we have gone through other minor advances that I will not recall now, I just mentioned, because I'm finishing. And what I wanted now to say before finishing is just to say or to recall about the figure of Andrea Milani that unfortunately passed away last year. And thanks to him, we have most of these systems now migrated to ESA after the large effort and all his ingenuity in developing those systems in the past. Thank you. Any questions?
Yeah, we have time for a couple of questions. Do we have any questions? Yes, go ahead.
Hi, Jan Osberg with RAND. So NASA JPL also has a database, of course. What would you say are the main differences and in the functionality or maybe on the back end? And have you found any differences in orbits or risk assessment between the two different systems?
That's a good question. Well, the two systems have been obviously developed independently, and the good thing about it is that they are used actually to validate the results in what regards, for example, impact monitoring. So, whenever the values of an object come to values which are to be taken into account, some impact probabilities that are large, there is actually a comparison on the results in order to to check that they are compatible and that the information is actually that is going to be provided to the public is coherent. So yes, in principle, the comparisons have been made, are reasonably good, not perfectly completely in agreement because they are two independent systems. But when it comes to cases where we have to put care and see and provide information on a threatening object, there is an agreement to compare the results and come up with figures that are coherent. Thank you.
Great, thank you very much. So thanks. We'll move on to our next speaker now.